Good day, greetings. How are you guys doing today? Welcome to, this is a chemistry lesson. Welcome to this chemistry lesson. Today we are looking at mass and molar concentration. Right, so in the previous lessons, lesson 12, lesson 11, we were looking at, we said we had now moved into this topic known as stoichiometry. We talked about the mole, we talked about empirical formulas, but you will find that this topic is, as I said before, heavy on calculations. And for us to do those calculations, we must know what those calculations are based on. Right? So there is something known as concentration. Whenever we deal with substances, chemicals in chemistry, we always want to know what the concentration, if it's an acid. If you remember in grade 8, grade 9, we'll just say strong acid, weak acid. But there's actually a concentration to say if you find 1 molar sulfuric acid, 2 molar sulfuric acid, 3 molar sulfuric acid, the concentration itself tells you how strong an acid is. It tells you how strong a particular substance is. So what we're going to do in this lesson is we're going to define mass, concentration, then we're going to define and describe it. We're also going to describe molar concentration, okay? And show how to calculate the mass concentration and the molar concentration, setting us up for maybe more difficult calculations to come very soon, okay? So those are our objectives for today's lesson. So just make sure that you have an idea, a grasp of what concentration is. Try to think of concentration in your own words to say, what do you think of when you hear the word concentration? Okay, so the concentration of a solution gives us an idea of how much solid is present in a solution. The concentration of a solution gives us an idea of how much solid is in a solution. So if we had a beaker of water and we poured, let's say this is salt, and this is the solvent. Let me just pull this back a bit, right? So this is a beaker of water, right? And this is, the reason why I say salt is because salt is something that is easy to remember, or sugar. But whatever you're going to put into the water, that's supposed to dissolve in the water, is the solid, right? That is the solid. So this is the solid that you're looking at, right? This is the solid. Okay? And then this is, the water is the solvent. The powder that you put in the water is the solid. The water is the solvent. And then when you mix the two, what you get is the solution. Right? That's actually what they're called. I hope that all of you guys knew this basic information. So when we're talking about concentration, right? When we're talking about concentration, imagine when you have poured salt. Let me give sugar instead. Let's say you've poured sugar into a cup of tea, right? You have poured sugar into a cup of tea. How many spoons of sugar do you take with your tea? You guys, you will tell me in the lesson how many spoons of sugar you take with your tea. Some of you maybe in a single cup, maybe take 4, some 5, some 1. Some take it with no sugar at all, depending on health issues and stuff. But if you put 6 spoons of sugar in your tea, you will find that it's going to be sweeter than the tea where you only put maybe 1 spoon of sugar, right? This is based on what? The number of particles of sugar that you have placed, right? That you have placed in your cup of tea, right? So if you have a cup of tea, a cup of coffee, if you put 3 spoons, right? The number of particles are obviously going to be more than when you put 1 spoon. So the one that has more spoons can be said to be more concentrated, whereas the one that has less spoons can be said to be dilute. It can be said to be dilute. Okay, so now if we have placed this mass, this solid that we have placed into the solvent First, in chemistry, because it's a science, we are going to measure the mass, right, of whatever solute we are going to put into our solvent. So if we had 50 grams of sodium hydroxide, 50 grams of sodium hydroxide, if they are dissolved in 1 liter of water, imagine a container with 1 liter of water, and we put in it 50 grams of sodium hydroxide. These 50 grams of sodium hydroxide are going to dissolve in the water. And we're going to say the mass concentration is 50 grams per every liter. 50 grams per every liter. Right? I just gave this one as a simple one. Let's imagine if it was 50 grams and it was placed in 500 milliliters. What would the concentration be? What would the concentration be? Okay, so if we had 50 grams and it was placed in 500 cubic centimeters or 500 milliliters, your concentration would actually be 100 grams per liter. I will explain it in more detail. Right now I'm just going to explain the issue of the units because I don't want to take long in this video. So, an important fact that I mentioned here was that now when we're looking at molar concentration, when we're looking at mass concentration, mass volume concentration, we don't use liters. We use cubic decimeters. We use cubic decimeters. And 1 cubic decimeter is equivalent to 1 liter. So when we're in chemistry and we say please bring us 2 cubic decimeters of ethanol, and then you say 2 cubic decimeters, where am I going to get these 2 cubic decimeters? It's just 2 liters of ethanol. I hope you are still here. So the mass, when you just dissolve a certain mass of solids in a certain volume of liquid, you immediately have the mass concentration. You just say, I dissolved 1 kg of sugar in 1 liter of water, therefore it's how many grams? It's 1,000 grams per cubic decimeter, because you're going to change it. Our mass concentration is given in grams per cubic decimeter. So if you're given 1 kilogram of sugar, you're going to say 1,000 grams per cubic decimeter, right? Then we have molar concentration. Okay, I hope you can pause the video if I'm rushing. You can pause the video, go back, look at the concept of concentration, mass concentration, before we just move on to molar concentration. Okay, so now with molar concentration, you now have to be in a position where you know how to calculate the number of moles in a given amount of a substance, right? Let's give the base. You remember the standard unit which we use, the carbon 12. To say if you have 12 grams of carbon, it means you have 1 mole of carbon. That means if you have 6 grams of carbon, how many moles of carbon are you going to have? If you have 12 grams of carbon, that's 1 mole of carbon. What about if you have 6 grams? 6 grams is equivalent to how many moles of carbon? It's equivalent to 0.5 moles of carbon, because it's half of 12, right? Whenever you're given the mass number of a particular atom tells you to say if calcium is a mass number of 40, then 40 grams are equivalent to 1 mole. Now, with molar concentration, we are going to say amount of substance, because we're going to be given the mass of a substance. We're going to be given the mass of a substance, and from that mass, we can calculate the number of moles that are there. Right, so now remember, when we're calculating concentration, molar concentration, we're going to say moles over volume. We're going to say moles over volume. Then for us to calculate, we have a triangle. Okay, we have a triangle that we use. Let me just have this triangle show up here. Okay, right. So concentration is moles per cubic decimeter. So the moment you are able to calculate the moles The important part you'll find is that if you know that you are given a certain amount of a substance, and you know how to calculate the number of moles, it means you are already home and dry. Because the moment you are told that you have 40 grams of calcium or you have 35 grams of calcium and they are poured into 500 cubic centimeters of water, what is the concentration, what is the molar concentration of this liquid, you then know that this 35 grams will translate into how many moles. You calculate the number of moles first, the volume is given, and then you just put the value you have found for the moles and you divide it by the volume and you get the what? You get the concentration. Right? The volume is in cubic centimeters, decimeters. So 1,000 cubic centimeters is equivalent to 1 cubic decimeter. 1 cubic decimeter is the same as 1 liter. I have already mentioned this before. Let's look quickly at an example, right? So here we have an example where we have 45 grams of sodium hydroxide is dissolved in water and made up to a volume of 250 cubic centimeters. What we should do is to calculate the concentration of this solution. The first thing, because now look, this is sodium hydroxide, and sodium hydroxide is a compound, okay? That's the good thing. In this example, we're using a compound. And this compound, we must still determine the molar mass, or even if you want to say molecular mass, of sodium hydroxide. So you have to go back to your periodic table, look for the mass of sodium, 23, mass of oxygen, 16, mass of hydrogen, 1. You add them, you get a mass of 40, right? So you know that 40 grams is going to be equivalent to what? To 1 mole. 45 grams will be equivalent to mole, right? 45 grams will be equivalent to mole. Let's see if I did this one correctly. You are supposed to have it, please, as, let's have it as 45 divided by 40. I'm going to make a correction on this one. Let's see. Mass over molar mass. Mass over molar mass. The mass that we're given there is actually 45. And then we're saying 40 divided by 45. I'll correct it. I'm trying to see why it was 40 divided by 45 cannot be 1.125. Just looking at it, I know that if we say 40 divided by 45, it's going to give us a number that's not bigger than 1, because 40 is smaller than 45. Instead, it should be 45 divided by 40, which will give us 1.125. Okay? And now you've calculated the number of moles, right? You've calculated the number of moles that are there in 45 grams. So 45 grams is 1.125 moles. For you to then calculate the concentration, you're going to say number of moles divided by volume. Number of moles divided by volume is, you are now taking this one, the number of moles, which is 1.125, and you are dividing it not by 1,000. Don't just rush to say we saw that other question having 100, so we started dividing everything by 100. We saw that other question having 1,000, so we divided everything. No, this one, the volume is 250. You divide by 250, you get 4.5 moles per cubic decimeter. That will be the concentration of this particular solution. Okay? That will be the concentration of this particular solution. Let me see if there is anything I want to show you from this one. Right? Obviously just volumes and how you get to calculate. Right? If you want to calculate your concentration and you are given moles and volume, right? You know that you just say moles divided by volume. If you want to calculate the moles themselves, it's concentration times volume. If you want to calculate volume, it's moles divided by concentration. You know how these triangles work. You know how these triangles work, right? So that is our lesson for today, right? This is not your lesson. This is a different lesson. Yours is this lesson. Okay. So that is our lesson for today, lesson 13, mass and molar concentration. So guys, I know you're watching the video right now. We're going to be discussing it immediately. So thank you very much for watching the video. Goodbye.